All right, let's start upping the difficulty level and trying to see as much variation as we can. So we'll have a couple more after this, and we'll keep ramping up the difficulty level. And you're just trying to make certain that you recognize all these different types of patterns because they're pretty much infinite. But with time, you start to recognize most. So let's go. We got our first one. So nothing too crazy about this. It's a fairly straightforward one, but we haven't dealt with anything quite like it yet. So this time we're using z's, and you can tell that that's the variable we're interested in by the dz. It can be any picture, it can be in Greek, it can be any letter. Just got to be used to it. So we typically find our u's either in functions or in denominators, and we can see here that z cubed, if you take a derivative, you'll end up with 3z squared, and that will cancel with the top. But we're going to have a little bit of a constant left over. So let's take the whole thing. And when you find u's, you always want to take that constant with it. So we have u is equal to z cubed plus 1. Now we'll take our derivative on u, and we're going to get 3z squared dz. Cool. Well, what we're looking for here is we want z squared dz. That's right here. So we actually need to take that 3 and divide it over. So we have 1/3 du is equal to z squared dz. Now we have a match, so we can replace. Okay, so let's set it up. Now have a process. Do it the same way each and every time. Each and every time. Do it the same way so you don't have any of that variation. You get weirded out. So I like to always start. Replace. You got your z cubed plus 1. That's you. All right, there's the first one. All right, now I'm going to move and go, all right, well, now we have to take our z cubed dz and replace it with 1/3 du. So I'm going to do something silly at first and put the 1/3 up top like this and then write in du. And you can do that, but I don't want to add an extra fraction. It's going to make me think I need to do more work. I want to use the idea that you can just yank any coefficient out to the front, any constant. So what I'd like to do is get rid of that 1/3 and put it out front. 1/3 times the integral of 1/u du. So, as we all know, the antiderivative of 1/u, oh, come on, man. Come on, man. That is the natural log of the absolute value of u. And then we'll put in a plus c. You need that absolute value. Anytime we take an antiderivative on 1/u, it's going to be the natural log of the absolute value of u. And now, since we started in terms of x's and there's no bounds, we have to end in terms of x's. So 1/3 the natural log of whatever our u was, and our u was z cubed plus 1. And there we go. We have ourselves a solution. We're not quite to test level stuff yet, but we need to be good with these types of problems. Moving to the next. Hey, there we go. And this is an opportunity for ourselves to see if you don't know your derivatives from Calc 1, you're screwed. I just want to be blunt. I mean, I don't want to be like, oh, you'll be fine. Now, if you've forgotten them, stuff happens. But you need to make certain that you know all those derivative techniques, because we need them as well as antiderivative techniques. So we're going to start off. And again, sometimes we don't know what to do. Sometimes we're not certain as to where to start. So we always want to think, if you're going to start somewhere, look for denominators. There's no denominator. Or look inside of functions. Hey, there's a 5 to the power of x inside a sign. Let's just start with this. And in Calc 2, sometimes you just have to be okay with the idea that you might choose the wrong one first, but then you just process of elimination. Okay, so u is equal to 5x. 5 to the x, my bad. And we take a derivative on this, and this is where I think a lot of us may have forgotten. We don't take derivatives on this very often, but it does happen. This is the natural log of the base, natural log of 5, times 5 to the x, dx. All right, so at this point in time, we've already found our u, but now we want to find our, we got to get rid of this 5 to the power of x dx. 5 to the power of x dx. We need to divide out that natural log of 5. So we get 1 over the natural log of 5 du is equal to 5 to the power of x dx. Now we have it. Now we can go through and we can replace what's in pink excuse me, with the 1 over the natural log of 5 times or du. I don't know why I said times. So once again, we're going to do this in the same way. I'm going to rewrite sine. And I always like to replace my u first. I just have a process. You should have a process too. So u is equal to 5 to the power of x. We put in our u. And then we need to take out that 5 to the power of x dx, which is 1 over the natural log of 5 du. Now, 1 over the natural log of 5 is just a number. I want to put that out front. It's just noise. We're going to leave it there. All right, so now let's take a derivative. Or antiderivative. Come on, man. So it's 1 over the natural log of 5 times. And what's the antiderivative of sine of u? Now, when it comes to sines and cosines, and you take antiderivatives, take a pause for a second. Just a quick pause. Just the derivative of cosine is negative sine. Oh, so the antiderivative of sine must be negative cosine. So now we got to go through, replace our u. So I'm going to yank the negative to the outside, 1 over the natural log of 5 times cosine of, and that's 5 to the power of x, plus c. And we have our solution. Knocking out another one. But this one was mostly just to show you that, hey, we got to know the derivative techniques. And there's a few that we'll forget, but we got to just remind ourselves and go. All right, so if you've ever taken a Calc 1 class with your teacher, you will know that this is the one that pissed me off. Actually, the problem that I had for my Calc 2 teacher was a +1 underneath there. And it stumped me on the test. I didn't know how to do it. So let's go get it. So now we have bounds. So there's not going to be a plus c. We're not going to have to go back to x's. We're just going to need to change our bounds. Now this is where I got stumped. I didn't know what to do because I looked and I'm like, well, I want to choose x plus 2. Go through, be like, well, u is equal to x plus 2. But then when I took a derivative on this, it was just, wait a second, what the hell do I do with this? How am I supposed to replace it? There's no x in here. Oh, I was frustrated. It's amazing your failures will stick with you. 10, 11 years ago, and I still remember this silly problem. It makes me cranky. I didn't realize that there's this little trick that we could do by manipulating our u. Because we don't mind if we have a square root of u. We just can't have a square root of like u plus something. But we can have it outside the square root. That's not a big deal. So the game is we want to subtract out our 2 on both sides. And we find out that u minus 2 is equal to x. So we could actually replace that x with u minus 2. We can replace our dx with du. And then there's our x plus 2. Oh, goodness. So I'll mess with the bounds in just a second. So always starting off the same way. Well, the square root of u now, right? That x plus 2 turns into u. And then instead of writing in our x, we put in u minus 2. Now instead of dx, we're going to put in our du. And this is going to be integrable now, or we'll be able to find an antiderivative using the power rule. But let's change our bounds. Let's do this now so we don't have to go back into terms of x's. So when x equals 7, our upper bound, our u is equal to 7 plus 2, which is equal to 9. Hey, there's our new upper bound. When x is equal to 2, our u is equal to 2 plus 2, which is equal to 4. How convenient. Okay, now let's go through and solve this problem. Well, I'm going to do a quick thing. You got a pencil, don't you, or something you can erase with? I don't like the square root. The square root sucks. I'm just going to change that to a 1/2 power. And then we can use a little thing called algebra. So we have our integral from 4 to 9 of u to the 3/2 power, that's u times u to the 1/2, minus 2 to the 2 times u to the 1/2 power du. I don't know if these numbers are going to turn out cleanly. I thought I was being crafty at the beginning. I think I might have screwed that up. Pretty good at that sort of stuff. But let's see what happens. So let's go get ourselves an antiderivative. So we're going to take the antiderivative on u to the 3/2 power. So we got to add 1 to our exponent. And then we're going to divide by 5/2. I'm lying. We're going to multiply by its reciprocal. It's the same thing. Now we're going to add 1 to our exponent here. That's going to be u to the 3/2 power. And then we have our 2 times. And then we multiply by its reciprocal. And then we evaluate from 4 to 9. Now let's see how we could do this without a calculator. Because we don't need a calculator for this. We got it. We got it. We got it. Sorry, just rewriting this in. I think I did okay with the numbers. I think we're going to be able to do this. Here's the kind of the trick. Because you're like, well, how the hell am I supposed to do this? I don't know what 9 to the 5/2 power is. Maybe you do, though. Maybe you do. These numbers are going to get big. These numbers are going to get big. So there's going to be our first one. Minus, right? So we're going to put in our 9s. But I like writing the whole thing out. Oh, so you wanted to be a STEM major, huh? Look at all these frickin' fractions and exponents. So now we're going to put in our 9. But I don't want to do 9. I want to put in 3 squared. I don't want to do 4. I want to do 2 squared. And that's going to be the trick as to how we're going to get this thing just to pop right out. I mean, the numbers are going to be gross, but let's see what we got. Let's see what we got. Now, when you multiply exponents, what's 2 times 5/2? No, the 2 times 5/2 that's right here. That's just 5. That's just 5. So right here, I'm going to cheat as I go through. This is just 3 to the 5th. The same thing's going to happen here where the 2's go away, and you're going to have 3 to the 3rd. So I'm going to cheat again, call that 3 to the 3rd. Next, we're going to go over and we're going to see that this is going to continue to happen. The 2's are just going to cancel, leaving you with 2 to the 5th. So cheat again, and that's times 2 to the 5th. And lastly but not leastly, these 2's are going to go in. You're going to be left with 2 cubed. Like I said, these numbers are going to get quite large. I'm like trying to think here, 3 to the 5th, and we've been going for way too long. I don't like my videos to be this long. That's 243. 3 to the 5th is 243 divided by 5, or times 2, divided by 5. So we end up with 486 over 5. 3 cubed is 27. 27, and then we're going to lose 1. 9 times 4, that's minus 20. 36. Keep going here. You got 2 to the 5th, that's 32. 32, that's 64. Oh, did you see how I dealt with the negatives? They got to come in and distribute to both. 2 cubed is equal to 8. 8 times 4 is equal to 32. So we end up with 32 over 3. 3. All right, so now let's put everything together. 486 minus 64. 486 minus 64. We get 422 over 5 minus 36 plus 32 over 3. So now we need a common denominator. And let's go get it. So 422 times 3 is equal to 1266 all over 15. We need to multiply 36 by 15 to get our denominator, so that's 540. And then we're going to have to multiply 32 by 5, and that's 160. So now we have 1266 minus 5, minus 540 plus 160. We get 886 all over 15. Let's make sure that doesn't reduce down. 8 plus 8 is 16. 16 plus 6 is 22. 22 is not divisible by 3. Therefore, we got the answer. Sorry for such a long video. Did it under 15, but my goodness. So how's your fractions, y'all? All right, I'll see you in the next.